Hey guys, here to do lesson 6.6. Let's start with our learning target. I will be able to write expressions. Nothing's changed from the last couple of lessons. Sorry, let me put my phone on vibrate. All right, starting with your think about it. It says, Matt is 5 years younger than his brother. His brother's age can be represented by the variable a. Select the expression or expressions that represent Matt's age. We have A, B minus 5, B, 5 minus A, C, M plus 5, or D, A minus 5. It also wants you to explain how you selected the expressions that represent Matt's age. So go ahead and pause the video, see if you can figure it out on your own. All right, guys, we're back. So if Matt is 5 years younger than his brother, okay, so 5 years younger, let's mark this up. Okay, so that means we're gonna have to subtract 5 because we're gonna take his brother's age and subtract that. Subtract 5 from that since Matt is 5 years younger. His brother's age can be represented by the variable a, so it's telling us what variable we should use. Okay, select the expression or expressions to represent Matt's age. So we have b minus 5. Well, it told us that our variable is a, so this looks kind of right, but it's not 100% correct. Okay, we have B, 5 minus A. Well, I said that I need to take his brother's age, A, and then subtract 5 from that since he's 5 years younger. So that doesn't work. M plus 5, that doesn't work. A minus 5 is what looks good for this expression. So why did I select D? Well, I selected D because, let's see, I'm going to change colors. The text told me to use the variable a. And it represents Matt's brother's age. The text also said that Matt is 5 years younger than the brother. So I would have to take his brother's age, A, and subtract 5 to find Matt's age. So one big key thing that this is basically trying to tell you guys is that it's important to be extremely specific when stating what your variable is. You want it to make sure it correctly represents the context given. Okay, so for example, we wouldn't want to say that A is Matt's brother because then that would mean I would have to subtract 5 from Matt's brother. And does that make any sense? No, that's why we said that A represents Matt's brother's age. We were very specific about what A represented. And if you put that in the context of his brother being 5 years older and Matt being 5 years younger than his brother, that makes sense in our story. We're going to take 5 years away from however many years Matt's brother is. All right, let's move on. Our key point for today's lesson is different. It says mathematicians define variables specifically when writing expressions. Okay, so we're very specific, like I just mentioned. Okay, so example number 1. Miss CL has 25.5 pencils, and Miss Orr has a certain number of pencils. Write an expression that represents the combined number of pencils Miss CL and Miss Orr have. So let's mark up this text. It says Miss CL has 25.5 pencils, and Miss Orr has a certain number of pencils. So we really don't know what that number is, so we're going to use a variable. The variable that makes the most sense would be P, because P stands for pencils. So if you notice here, we have a part, which is my part, and then we also have Miss Orr's part. And the question wants us to write an expression where we're combining those numbers of pencils. So the word combine tells us we're going to be doing addition. And that this is going to be our total. Okay, so let's apply our key point by first defining very specifically what our variable P represents. So let P represent the number of pencils Ms. Orr has. Okay, so we already figured out this is my portion is the 25.5, so let's start with that. We have the 25.5 pencils. And because we are combining, that tells us our operation is addition, and we have to combine the part that Miss Orr has, which we don't know what it is, so we put the letter P. So our expression that represents that story or that specific context is 25.5 plus P. All right, on to example number 2. Olivia has a certain number of pieces of candy that she wants to share evenly with her siblings. She has 2 sisters and a brother. Write an expression that represents the amount of candy each sibling will get. So let's start by marking up this text. Let's see, Olivia has a certain number of pieces of candy. So that sounds like that's going to be our variable. And since we're talking about candy, we'll use the letter C. Okay, and it looks like we're going to be sharing evenly. When I'm going to share evenly, what operation does that signify? Division. Okay, so it looks like we're going to take this total of the number of pieces of candy that she has and divide it evenly among her siblings. It says she has 2 sisters and a brother. So how many total siblings is that? 3. All right, again, we have to write an expression that represents the amount of candy each sibling will get. All right, so the 3 siblings, since we're doing a division problem, end up being our number of groups. We're going to have one group for the first sister, another group for the second sister, and a third group for the brother. And then our expression, what it's going to end up equaling is the amount of candy each sibling will get, or the size of those groups. So how many pieces of candy is going to be in each of those groups. All right, so let's start off by applying our key point and defining our variable. So we said let C represent the total pieces of candy Olivia has. All right, so if we're starting with the total and we're sharing it up, the total is what we're splitting, or is our dividend, and we're going to divide by the number of groups, which was 3 siblings. Okay, so we have C divided by 3. Can you think of another way that we can represent this same expression? How about C over 3 in fraction form? That's the fraction form of this division problem. Okay, remember remember that fractions are miniature division problems, and the fraction bar represents to divide. So both of those expressions represent our context from example number 2. All right, guys, I will see you for our Zoom meeting. Until then.